Day.
Perfect.
All right. Okay, everybody, can we start now? You are ready, yeah, guys, students?
Yes, yes, we are ready.
Okay.
Yes, we are ready.
Yes, ma'am.
All right. Thank you. Okay, Katrina, again, welcome to our summer course, and thank you so much for your valuable contribution. Will be valuable contribution your presentation today. Please allow me to just read your short bio, yeah, Katrina. Okay, Dr. Katrina Davis is Associate Professor of Conservation Biology at the University of Oxford, United Kingdom. The overall objective of her research is to identify optimal management of environmental resources to maximize conservation and human welfare outcomes. In particular, her science is focused on improving our understanding of the dynamics of social ecological systems, particularly marine systems. Her research combines demographic and bioeconomic modeling, non-market valuation, and optimization approaches. Her topical interests include human-wildlife conflict, assessing marine use and non-use values, and spatial marine management. All right, Katrina, now it's your time. Thank you.
Thanks very much, Melanie. It's really lovely to see so many faces today. Thank you to everyone who has their camera on. It's really nice to see you all. So it is 4 o'clock for some of you, even later for others. So we've got, I will do my best to make this lecture as engaging as I can to keep you all awake, because I'm sure you've had a long day already. So just to check that I'm fairly interactive in my lectures and my talks. So just to check, can everyone attempt to raise their hand on their either physically or with the raise your hand function in Zoom? Just checking everyone's got it. Woohoo! Yeah, looking good. Excellent. Okay, so continuing with our raised hand, can everyone tell me who's in an economics stream in their various studies, whatever their studies are? Couple of hands raised. Is anyone doing like a straight, yeah, lovely, that's lovely. Anyone doing like a straight biology? Is anyone in that sort of stream? No, I can't see any. What were some of the other areas? Was philosophy something that you guys were studying? Is anyone studying philosophy? Business? General business degree? What are the other, for those, I think it was maybe 80% of you who were not studying economics. Okay, forestry, there's one. Hands up if you're doing forestry. Good work, Mohammed. And a couple of others. Great. What else? Is anyone doing like a straight fisheries course? Anyone doing fisheries? Chemistry? Sustainable management? Who's doing sustainable management? Let me put the face to with the icon to the image. Okay, grand. And economics. Okay, good. So we've got a very broad mix, which is perfect, just how we like it. So guys, I've got a bit of a block here at the moment. So if at any point I'm speaking too quietly, I've got the chat open on my left-hand side. Just let me know and I will change the way I am speaking. So let me just, before I switch across to my slides, one final show of hands. Who works in some kind of marine setting? All of these people that are yet to be converted to the one true path of research. So no one works in marine settings. That's what I think you do. Okay, interesting. Well, that's right. I will convince you that marine research is basically the only way to go forward. So let me share my screen. Correct. Before I do that, apologies, guys. Let me put this into presenter mode first, and then I will share. Swap these. No, actually, I can do it this way. Okay. Okay, can you all just confirm that you're seeing the slideshow as opposed to the one that you're seeing the right screen?
Yeah,
Yep, great.
I
Okay,
can
great.
see it, yeah.
Like,
The presenter view? I mean, the actual, oh, you've probably got the chat open. Let me move that. Okay. Okay, I've lost your faces now. So guys, today I'm going to chat with you about the benefits and costs of marine protected areas. And this is one of the areas that's very close to my heart because it's where a lot of my research started. So I'm going to take you through some definitions of what marine protected areas are. Since none of you apparently are studying marine systems, that's fine. We'll get you there. And so my background is economics. My undergraduate and my PhD were both in environmental economics. So that's the lens from which most of my research is based, and I work in marine settings. So when you work as a conservation biologist in marine settings, you often work with marine protected areas. Okay. So this is what we're going to cover today. What are marine protected areas? MPAs. This is every discipline has their acronyms, and MPAs are very firmly a marine acronym. We're going to talk about why we have them, some of the outcomes that we want or expect from marine protected areas, and some of the economic and social impacts. And then if we've got time, I'm not sure if we'll have time, we'll get onto how we can design MPAs to incorporate a broader range of socioeconomic values, basically, and where this field of research is moving to. Okay, so what are marine protected areas and why do we have them? Has anyone visited a marine protected area before that they know of? Hands up or say yes in the chat. I can't believe that no one's visited a marine protected area. Maybe we need the definition first. So a marine protected area is effectively an area in the ocean where human activities are restricted in some way. So we can have some really charismatic, highly protected marine areas, and we can have some less charismatic, less protected marine areas. So marine protected areas come in all shapes, sizes, and flavors. Some are known as marine reserves, some are highly protected marine areas, and we'll speak a little bit more about what those definitions mean. And effectively, the concept of marine protected areas comes back to this big movement in conservation biology, where often referred to as fortress conservation, where we just thought, let's protect an area from human influence and see if we can improve the values that are associated with that area. So the IUCN defines protected areas as a clearly defined geographical space, recognized, dedicated, and managed through legal or other effective means, and effective is important to you, to achieve the long-term conservation of nature with associated ecosystem services and cultural values. So this definition has evolved a little bit over time as our concept of nature and how we want to engage with nature has also changed. But really important for us is that we're speaking about a clearly defined geographical space. And in terrestrial settings, this can be quite straightforward. In marine settings, this can be quite difficult, sorry. And this is the language that we had before the Millennium Ecosystem Assessment change of the IPBES report in, what was it now, 2020, 2018? And we were still talking about ecosystem services and cultural values. Okay, so why do we need marine protected areas? These are some old numbers now, but still, unfortunately, almost effectively true. So I'm sure any of you who works, well, maybe if you don't work in oceans. So we know that we live on a blue planet. For those of you who in Hawaii, this is, I'm sure, very obvious. So the ocean covers 3/4 of the Earth's surface. We have hundreds of thousands of species, probably more like millions of species. The oceans absorb about 30% of carbon dioxide produced by humans. And so this is a really important, depending on the lens with which you approach the need for ocean conservation, the carbon capture potential is a large one. And when we talk about blue carbon credits, blue economy, that's sort of the area of analysis that those are addressing. One thing that is often, it's a difficult number to get an exact figure for, but we tend to throw up these billions of numbers, are the number of people that actually depend on marine and coastal biodiversity for their livelihoods. And so most of us, I think, on this call would be living in coastal environments. And so that's obviously very apparent to all of us. So we know that as much as 40% of the ocean is heavily affected by pollution, depleted fisheries, loss of coastal habitats, and other human activities. But on the other hand, we know that the oceans generate this really large economic values. So US 3 trillion is the estimate here. This is really a difficult figure to estimate, but it's thought to be about 5% of global GDP comes from marine and coastal resources. So human pressures on the marine environment, these are varied and wide-ranging. As an Australian, I'm an Australian, most of the more salient impacts are mining, oil and gas extraction. I did my PhD in Perth in the University of Western Australia, and Perth, Western Australia has a lot of mining, oil and gas extraction. So those are some of the biggest concerns we have. Aquaculture, depending on where you are in the world, is becoming, on the one hand, it's our answer to depleted fish stocks, but there are some very serious and important considerations to be had around the pollution or other impacts that aquaculture can have on our marine and coastal settings. Dredging, engineering and construction, fisheries is an obvious one. Some of our land-based impacts, if any of you are is anyone working in agricultural studies? So nutrient runoff or effluent runoff from agricultural areas is a big problem for our marine systems, particularly our coastal systems. So if anyone's near coral reefs, this is a big problem for the Great Barrier Reef in Australia. Great Barrier Reef, which sort of straddles the north of Australia. Queensland, which is the adjacent state, is very, very, has a lot of agricultural activity. Lots of sugarcane, lots of really large farming area. And one of the biggest problems we have is understanding how we manage runoff, the nutrient runoff from these agricultural areas into the Great Barrier Reef. Other problems, reclamation. This is a big issue up in China with all of the salt marshes which have been reclaimed. Recreational activities, renewable energy, shipping and waste disposal. The full package, really. So from the policy perspective, this is where I'm just going to take you through a wee bit of the international policy or agreements that have really led to how we mandate or require marine protected areas to exist or to be constructed in our oceans. So I think most of you, if you've done sustainability research, will be very familiar with Rio de Janeiro, the 1992 United Nations Conference on Environment and Development. It was really from this conference that a lot of our ideas of sustainability were sparked. So these went down into other world summits on sustainable development, the Conference on Sustainable Development, Rio, and that was in Rio de Janeiro in 2012. And really from these conferences, or from that particular one, our Sustainable Development Goals were born. So I'm assuming some of you, your research will be touching on the Sustainable Development Goals in some way. These were adopted in 2015. So our Sustainable Development Goals with respect to the water, these of course were supposed to have been obtained by now, but we were talking about conserving and sustainably using the oceans, sea and marine resources for sustainable development. And there's some more numbers here around why we need to conserve our marine resources. So this was the UNDP Sustainable Development Goal. So the actual goal for this, for the Sustainable Development Goals was to have at least 10% of coastal and marine areas consistent with national and international law and based on the best available scientific information. We wanted to have those areas conserved. So spoiler alert, you can be thinking of this to yourself. Does anyone think that we have 10% of coastal and marine areas conserved already by 2025? We will answer these questions shortly. Okay, so that was the Sustainable Development Goals. On the other side, we not so much in the sustainable development area, but in the Convention of Biological Diversity, our policy focus on biological diversity. So we had our Conference of Parties on Biological Diversity, COP7 in 2004 in Kuala Lumpur. We reinforced some of our commitments to marine protected area networks. And it was in COP10 in Nagoya in Japan where we got our Aceh targets. And these are the very sort of popular charismatic targets which have now been replaced. But at the time they were saying that once again they wanted to preserve at least 10% of coastal and marine areas by 2020. 17% of terrestrial areas, but only 10% of coastal and marine areas. Okay. Now, of course, the most recent targets that we have come not from the Aceh targets, but from the Montreal targets from COP15. And so there was another set of 23 ambitious targets for 2030. They're all quite long and wordy. So this is target 3, and the important one here is that this is for terrestrial, inland, and coastal and marine areas. We've got the same target now. We wanted 30% of these areas protected. Importantly for us today, these areas were supposed to be effectively conserved and managed. I don't know if you can see my mouse here, but anyway, we wanted effectively conserved and managed marine protected areas, and we needed these ecologically representative, well-connected and equitably governed systems or other effective area-based conservation measures. And a big focus on the Montreal targets has been to make sure that in all of our targets or in all of activities, we're recognizing Indigenous and traditional territories, and making sure that our outcomes are consistent with respecting the rights of Indigenous peoples and local communities. So this is now what the conservation community is working towards. I just spoiled my previous question without any fanfare, but this is marine protected area coverage in 2025. So if you thought back to our early targets, we wanted 10%. We're currently tracking around 8.5, more or less. So apologies, I had prepared this lecture initially for a British audience, which is why you can see the coverage around the UK. So UK and Europe, they're very dense, very busy waters. There are marine protected areas. You can see that they're fairly sporadic in nature. But this is what MPA coverage looks like in around the north of Europe. So our marine protected areas have grown over time. When did I say the Aceh targets were? 2014, more or less. You can see that these are classified. So this is our years on our horizontal axis, and then we've got kilometers squared. So the size of our marine protected area or state. So areas beyond national jurisdiction are in our purple, and you can see they've barely moved, as you would expect. And it's our national and our global MPAs which have increased over this time period. So we can see these real sort of jumps after 2006 and 2014, and we've had a wee bit of a plateau in recent years. So those of you who work in governance or management of natural resources will understand that sort of designating an area as under some form of regulation is not necessarily the same as achieving the outcomes that are consistent with a given form of regulation. So it's no surprise probably to most of you that our marine protected area estate, our 8.5% of the marine's oceans, are not all protected equally. So you can see in these dark blue areas, these are the fully protected marine areas. Highly protected are these light sort of turquoise color, and then we go down in our protection through these colors. So immediately you might notice where our highly protected marine protected areas are located. And you might also be thinking to yourself, where are our most productive ocean resources, marine resources? And you might also then be thinking, where is population density highest? And you would be right in thinking that those are all in coastal zones. And so in our coastal zones, typically what we tend to see are these really sort of minimally protected areas, unknown status. And our big sort of highly protected, fully protected areas tend to be significantly offshore. And those of you who are working with economics can probably intuit that the reason for that is that the opportunity costs of locating fully protected marine protected areas in coastal zones is much, much higher than it is in having them offshore. And we'll get into the reasons for that. Okay, so this is the problem with this, of course, is that if we have areas where we are restricting human activities, and we do not actually achieve the restriction in human activities, we don't get any of the benefits from restricting human activities. So what we end up with are what's known as paper parks. So this is a term which was initially coined for terrestrial systems, but functions just as well in marine systems. So what happens is we'll designate a marine area as a marine protected area, but they're not actually achieving any protection. Okay. So here's some work that was done by Jane Lubchenko and colleagues in, I think it was 2020 now. Apologies, I've lost the date of this. What they did was they thought that they classified the different sorts of activities, human activities, resource use that they thought were consistent with different classifications of marine protected areas. So we can see that mining is never allowed in a marine protected area. It should never, by their classification, they don't think that mining is consistent with any classification of marine protected area. But the minimally protected areas can allow some form of use of all of these activities. So dredging and dumping, infrastructure, aquaculture. Oops. Oh, geez, that's my mouse getting excitable. No. So aquaculture happens in all marine protected area classifications, which is a strange one. Fishing happens in lightly and minimally protected areas, which some people would say were not consistent with the goals of a marine protected area. And non-extractive activities like tourism tend to happen everywhere, even in most fully protected areas. So what happens? So the economists amongst you will be thinking to yourselves, these are basically our indication of opportunity costs. We know that mining is a highly productive activity. Some of these others, fisheries, especially for employment purposes, aquaculture for food production, these are all important activities from an economic perspective. The difficult part comes in that when we have these economic activities happening in our marine environments, we don't actually expect to see any of the benefits of protecting those areas. So here, this is from the same publication. And what they're showing is some theoretical idea of what our oceans used to look like in the past. So we had lots of higher order predators. We've got lots of sharks in here, larger bodied animals, turtles and rays, filtering all the way down to our low trophic levels. This is the current state of our oceans, which are significantly more denuded relative to what we hypothesized was this previous idyllic state. And then this is what they expect are the levels of flora and fauna that we would see in our marine environments, depending on that level of protection. So when we keep everything out, except for some tourism, what we expect to see are sort of this setting, which is really similar to what we thought we had in the past. As we go to highly protected, we expect to lose some of these larger predators, these higher trophic levels. Lightly protected, we lose our predators, our higher trophic levels almost completely, and minimally protected is really not any different to sort of our base case scenario. Okay. So to remind me to take a breath, apologies. Okay. So giving you a background in the ecological outcomes that we expect to have from marine protected areas. And the ecological outcomes are important for a whole bunch of reasons. A, we're concerned about the conservation outcomes of marine protected areas. B, often our marine protected areas will be established with the goal of increasing fish stocks, so to help nearby fisheries recover. They'll be established with the goal of increasing tourism benefits or visitation to an area. And so it's important that we know what the benefits are that we're expecting from these marine protected areas, because that's going to change or influence how we design them and how we manage them, and also how we assess whether they're actually working. So all else being equal, what we expect to see is that marine protected areas will help address some of these abatable threats. So they're going to help us sort of buffer the impacts of fishing, mining, habitat destruction, but there's a whole bunch of threats that we don't think marine protected areas are going to do anything about. So these are nutrient pollution, ocean warming, and ocean acidification. So these are really not related to what's happening in the marine area themselves, but what's happening in the broader or adjacent environment. Okay, so the main benefits that we expect to see from marine protected areas are these ones. So we expect to see an increase in species abundance. So basically, we just expect to see more fish and other marine species. We expect to see an increase in species richness, so more different types of species. And we expect to see a difference in the biomass of our species. So we expect to see larger individuals. So those of you who are working maybe in agricultural systems, in marine systems, there's a general rule that the larger an organism is, typically the more fecund or the more it's more reproductive. I don't know if I can even say that term. We expect to see higher rates of reproduction in larger species. Those of you who do have any work to do with fisheries will know that the general thinking is that in fisheries we've worked our way down the food chain, and so we've gone for increasingly we've worked our way down trophic levels, taking the larger individuals first. And that's really problematic because typically those are the most highly fecund individuals. So in marine protected areas, we expect to see a reversal of that trend. And the important thing here is that we'll get onto timelines. But also we expect to see an increase in the resilience of our coastal zones. Those of you who live or work around coral reefs, other coastal zones will know that resilience is a really important benefit from a societal perspective, because we expect to see, sorry, I'm just saying, share the background of the speaker. Oh, okay. So we expect to see an increase in the coastal protection, so protection against storm surges or tropical storms. And so this resilience factor is one of these really important benefits. Okay. These are some studies that have looked at whether we do actually see any of these benefits in marine protected areas. On the left-hand side, this is a meta-analysis which was done in 2009 now. And this is a change in the biological measure of interest going all the way down into negative changes. So maybe marine protected, sorry, my mouse gets excitable. And then we're, so negative benefits from marine protected areas all the way up to positive benefits. This is a discontinuous axis. So here you can see that they sort of saw large increases in the biomass of species. So we mentioned that. The density, so the number of species. We didn't tend to see this increase in richness, which was interesting. We'll come to that. On the right-hand side, anyone else has a Mac? I've found that my mouse is getting excitable in recent updates, and it just wants to scroll forward or backward, depending on what I do with it. So on the right-hand side, I won't touch the mouse. This is a study by Ross and Alcala. Again, this is an older one now from 2004, and this is all about the Similian Island in the Philippines. So what they found was that mean biomass is on a vertical axis and years of reserve protection are on a horizontal axis. So here's our control. I'm going to zoom in. So here's our control sites. So these are not marine protected areas, and these are our reserve sites. And you can see after just a few years of protection, we're seeing quite strong, mean biomass has increased or doubled just over a 5 to 10 year period. What's important here is that the expectation is that these levels of increase are not going to continue through time. They will flatten out. But if we look at this, again, this is a different island. This is Similian Island after 15 years, and Apo Island where they had the longer run. What's important is that some of our species really don't start to show signs of recovery until this 15-year period or until our 40-year period. And this is basically because the life histories of these different species can be much, much, much slower. So if we have species that reproduce once every 8 years, once every 10 years, once every 20 years, we're not going to see any benefits from protecting those species in the short term. And this can make it really difficult to justify the costs involved with marine protected areas because the benefits are expected so far into the future. But it does tend to be why we don't see an increase in richness initially from studies of marine protected area effectiveness, because most studies are not assessing the benefits over the last 40 years. Okay. So we've spoken about increases in biomass, abundance and richness. Sort of more important, almost from a human welfare perspective, is this idea of resilience, that marine protected areas increase the resilience of sites. So this can be important for climate invasion. So typically we think that healthier marine communities are more resilient to invasive species. If we're thinking about corals, then we're definitely thinking about bleaching events. We know that coral reefs, which are protected, are more resilient. They bounce back quicker from bleaching events. And they're also more resilient to agricultural runoff. Here's a study showing exactly that, if you are interested. So this is some work by Amanda Bates and Graham Edgar and other colleagues looking at the resilience of reef fish communities. What they did find is that they saw that in marine protected areas there was this resistance to colonization by these subtropical vagrants, which is more important because we expect to see more of these subtropical vagrants as climate change increases. Okay, and then reference sites. So for all of us who are sort of designing any form of policy intervention or conservation action, what is typically really difficult for us is it's very difficult to say what would my environment have looked like without this intervention. And we're about to do some work on this now. So what we find in marine protected areas is that they can give this this base case setting. What would our marine environments, how productive would our marine environments be if we didn't have fishing, if we didn't have mining, if we didn't have dredging or aquaculture? So we can get this counterfactual from marine protected areas. Okay. So the benefits that we see from the ecological benefits that we see from marine protected areas are primarily related around typically these two really large economic activities. One is our fisheries. So we're pulling fish or other marine species out of the water. And two, typically it's our mining or our aquaculture. And these are typically associated with habitat damage, although fisheries obviously can be associated with habitat damage. So we expect to see when we stop pulling marine species out of the water, or we stop damage to marine habitats, we expect to see the benefits that we've just discussed previously. The challenge, of course, is that stopping fishing or stopping mining have very strong opportunity costs involved. And in order to justify those opportunity costs, we want to be able to assess the ecological benefits and say, yes, it was worthwhile not fishing, it was worthwhile not mining, because we've seen these great increases in species abundance or richness or biomass. So the problem, of course, is that we have our methods in order to assess these changes are limited, as they are in every system, by the sort of data that we had or the design of our system. So what we want to see, we're going to show you a series of figures here. So on our horizontal axis is time, and on our vertical axis is value. So we're thinking about some value associated with establishing a marine protected area. So the lighter, the sagey green line, the top line, is our trends in our value over time when we have a marine protected area. And our red-ish color is the trend we expect to see without a marine protected area. And when we're designing a policy intervention, when we've got some kind of intervention in a system designed to achieve an outcome, I think this is typically the most this is the setting that most people will think of. They'll think about a time period, time 1 here at time 0, when we establish the intervention. So here we established a marine protected area. And then after time, we're going to measure the benefits, and we expect to see this increase in benefits, maybe slow at first, but then increasing over time. And then if we don't have our benefits, if we don't have our intervention, the typical expectation is that our ecological system will just continue at a flat line, right? Nothing else is going to change. And then we can take the difference between 2 and 3, which is really just the difference between what happened when we started versus what happened now. And we can say, well done, everyone. That is the impact of our intervention. And it's worked, right? Because our 0.3 on our benefit scale is higher than our 0.2 or our initial value. So this is a problem that we often have when we're justifying environmental offsets. If anyone's familiar with offsets work, it's very difficult to say what would have happened if our development didn't happen, if our mall wasn't built, if our houses weren't built. What would have been the trajectory of our environmental system? Okay, so our next setting comes from what perhaps is maybe more typical in environmental systems, that we started off at some unit of biological value, and over time, without the marine protected area, our actual biological value would have continued to decay. And so we still got the same level of biological benefits, but if we assumed that the biological benefits were only the difference between 1 and 3, we'd be grossly underestimating the impact of this intervention. By contrast, if we had a system like this one in panel C here, maybe we would have had this continued decay without environmental benefits, but we are only observing 0.3, which is what's happened to our environmental benefit of interest, with the marine protected area. So if you're in a naive policy setting and you haven't done any impact evaluation and you're only observing this outcome, 0.3, associated with your marine protected area, you're very likely to say that intervention failed, right? We actually had a decrease in environmental condition over time with the marine protected area. That's not the case. We know that we've still avoided some sort of deterioration or habitat damage with the marine protected area, but there's still been this decline. And then conversely, it may have been that the trajectory of our environmental setting was actually improving over time. So even though our marine protected area has increased outcomes relative to our base case scenario, actually the impact of the MPA has been minimal and probably no significant difference at all. So those of you who are assessing, who are doing any sort of causal inference or assessing the impact of interventions, what you'll know is that we can observe outcomes at 1 and we can observe outcomes at 3, but it's extremely difficult to come up with a valid 0.2. So here we have to, what is our counterfactual against which we're measuring the benefits of our intervention? So in marine settings, what is typically done is we look for a marine area that looked very similar to our marine protected area. Maybe the climate was similar, the levels of human influence were the same, and we're going to observe how that area has changed over time. So we'll pair our observations. This is very similar to what's done in a lot of the red forestry schemes. We're going to look at an area inside a red forestry area and an area outside of this red forestry scheme, and we're going to compare the levels of deforestation, and if they're lower in our red area, then we say, well done, everyone. We've done appropriate things. The problem in marine settings is that we have a very fluid environment, and what is going to affect our counterfactual, A has a really strong temporal signature that we need to account for, and B is highly influenced by what's happening in the rest of the region. So the easiest one to think of, I think, for most of you is that if we had, and we can think of this in a terrestrial setting as well. In a terrestrial setting, we've had a long history of land clearing. So we've got very little native vegetation, or we've got very little vegetation. We've got no seed bank from which to observe an increase in vegetation, right? Because we've already cleared an area, it's much more difficult for that area to recover through time relative if it was already forested. In the same way for marine settings, if we've had a really strong fishing or a very intense fishing activity in an area before establishing the marine protected area, it's going to take a lot longer to see any of the benefits from the marine protected area. Similarly, if we've got changes in climate that are occurring elsewhere in the region, they're going to impact the trajectory of our change, coastal management, or invasive species. So in marine settings, to justify that our marine protected areas are working, we can rely on matching and statistics, but effectively we have a very difficult task because it's ultimately, you're never going to be able to guarantee that the counterfactual setting you've chosen is appropriate, is the appropriate setting. Okay, so this, of course, what we do instead is we go to regression analyses and we say, of the marine protected areas which have been successful, what are the features of those areas? So this was work by Graham Edgar and colleagues. This is getting on now a little bit, this paper. But what they did is they did a really large meta-analysis of all the marine protected area literature, and they found that marine protected areas which were successful had these 5 characteristics. And so they were no take, which means that there was no level of fishing or extraction of marine species allowed. They were well enforced, and we'll come to well enforced later. They were old, so they had enough time for species to recover. They were large. Again, we're talking about the habitat ranges of species. So some species just have larger home ranges and they require larger areas. And then these areas were also isolated by deep water or sand. Okay, so some of the reasons why our marine protected areas may not provide ecological benefits. Those of you working in terrestrial systems in forests or agricultural production, the terrestrial realm is far more discrete. It's much easier to box it off and say, we're going to manage what happens in that area. There are some diffuse impacts. Acid rain is probably a really good example. But relative to marine settings, it's much harder, to terrestrial settings, it's much harder to have a discrete intervention in a marine setting because of this fluid environment. So these are some of the reasons I've just mentioned. There's marine species of larger horn ranges. Connectivity plays a bigger role. They're harder to monitor and they're more difficult to communicate and enforce. So the second reason is this history of what humans do in an area before or after a marine protected area is established. So if anyone is working in forestry or in land clearing is a big issue in Australia. And what we typically see in a land clearing setting is that if there is an expectation that regulations are going to change about the level of clearing that can happen in an area, there is an incentive for people to clear the area preemptively because that opportunity may have been taken away from them, may be taken away from them in the future. And we see it's been coined the blue paradox by the authors of a particular study, which I'll show you, which is this one, Chris Costello and colleagues. And it's this idea that with the expectation that a marine protected area is going to be established, what we have observed in many settings is that fishing activity will actually increase prior to that designation. And of course, if we increase fishing prior to designating a marine protected area, we basically delay the trajectory of benefits through time. And then the third problem that we tend to have is jurisdiction. So those of you who are in island nations will be well aware that how your neighbors are managing their marine environment has a really strong impact on the outcomes that you will see in your own marine environment. So, for example, these authors were looking at the spillover effects of sea turtle protection in the Hawaii longline swordfish fishery. So what we can often do in marine settings is if we change how we are managing a mobile species in our own jurisdictional area, we are just pushing out exploitation or some of the impacts of overexploitation of that species into other jurisdictions. Okay, and then we come to the economic and social impacts. I'm just going to take, if anyone would like to take 2 minutes to grab a drink, please do so. I'll start back in 2 minutes' time.
Take your time, Katrina. Just take your time. It's all right.
This is a difficulty with not being in person. If it was in person, I'd let everyone stand up and walk around the room.
Everybody, if you want to have a drink, yeah, come on.
Yep. Walk around.
Yeah, walk around.
How many minutes we can?
Sorry, Zada. Sorry, Zada.
Yeah, but how long we can walk around and take a break?
2 minutes. 2 minutes.
Oh, that's so short. You can blink an eyes. I think Katrina should give us more time, 5 minutes or less.
5 minutes.
Come on.
I will defer to the organizers.
Okay. We appeal you to just do loving for us, giving us 5 or 10 minutes more.
He's just joking. How many degrees in Oxford now, Katrina?
Do you know what? It's summer has finished.
Oh, really?
What is it? I'm just looking now. It's not that. It's Ireland.
Oh, sorry.
It is 21 degrees. No, it's 17 degrees. 17.
Oh, 17. Oh, yeah. Summer is finished.
Yeah. Never mind. What temperature is it there?
Here, about 30 something.
A little bit warmer. Just a little bit warmer.
Yeah. Tropical country like Indonesia is just 30 something all the year.
All the time.
Yeah.
When it's 30 degrees in the UK, everyone melts. It's way too hot.
Yeah, I know. Yeah, I went to Oxford yeah, how many 2005.
Mm-hmm.
And it's always cloudy. UK is always cloudy. London is always cloudy.
It's such a shame, but it's always cloudy. Yeah, I don't mind the temperature, but I do miss the sunshine.
Oh, sunshine. You come back to Australia. I'm an Australian. I live in Sydney.
In Sydney,
Yeah,
it's such a beautiful,
yeah.
yeah,
So
I
you
always
you
say
you coming
Sydney.
from Perth?
I'm originally from Armidale, so I'm a little
Armidale.
bit,
Oh, wow.
yeah. So I'm
New
originally
South
from,
Wales, Armidale. Wow.
yep, yep. So actually, Armidale has a very similar climate to the UK. It's maybe
Ah,
it's got more sunshine in the UK, but it's a colder environment.
all right. Okay. Interesting. Yeah,
Yeah.
yeah.
We were just in Brisbane though, actually, for the ICCB conference.
Ah,
It we froze to death in Brisbane. I took shorts and it was
in
winter in
Frost
Brisbane
to
is
the really just recently, Brisbane.
yeah.
Ah, yeah, it's cold. Is it Brisbane cold now? Because
Yeah, it's
Brisbane is
never really cold, but I suppose
tropical.
it's not summer either. Winter in Brisbane is not summer. So
Yeah, it's winter now.
yeah, yeah. Shorts were a little inappropriate, all things being considered. Yeah. I was convinced. I was convinced I would be fine in shorts, but no. But no. Okay, let's start back.
Right.
We need the little conference bell to signal. Okay, everyone, session is back on. Melanie, I'll let you to say when we start.
Okay. Okay, are we ready, guys?
Yeah,
Girls and boys? Brima?
yeah, Maran.
All right. All right, let's start.
Melanie, do I need to wait for you to be recording or are we still recording? I'll just start. Okay.
Yeah, it's all right. Yeah.
So everyone, we've just spent a whole bunch of time talking about the background of marine protected areas and why we might want them or need them from a conservation perspective or from a recovery perspective. And now perhaps closer to some of your hearts, given that if you're studying economics, is thinking about the economic and the social impacts of marine protected areas. So forgive the stock image, but we do know that marine protected areas are very important for coastal communities. And so typically, when we're thinking about the impacts of marine protected areas, we're not thinking about really large scale industrial commercial fleets, which are most highly impacted by marine protected areas, although they can be. We tend to think of the smaller scale fishers. And so typically, small scale fishers who aren't in mechanized boats, I think, are becoming less common. In the UK, smaller scale fishers are the less than 10-meter fleet, and they do tend to fish in the 6 nautical mile limit within the area of the national jurisdiction. And so if we are wanting to establish our marine protected areas in this coastal zone, what we're doing is really displacing typically our smaller scale fishers who, all else being equal, are having lower profit margins and are more reliant on their income from fisheries and are more vulnerable to changes in the trajectory of the fish stocks. So on the one hand, if we can recover fish stocks through our marine protected areas, then we have larger benefits for our local communities, but they are the ones who are experiencing the opportunity costs of establishment more quickly, sooner in time. So this is a typical feature of most environmental projects, but it's typical of all investment projects. Typically, all of the costs of establishing establishing an intervention are incurred upfront. And typically what we expect to see is that our benefit stream really starts accruing further into the future. So marine protected areas, we spoke about some of the benefits not accruing until something like 15 or 40 years after the marine protected area has been established. But every year that marine protected area is in place, those opportunity costs continue. So the main economic and social costs we expect to see with marine protected areas are again related to this idea that activities are being restricted in an area. And so typically for fisheries, that means that you're not fishing in an area, which means that the costs of getting to alternative areas are typically higher because you have to travel further, so you have increased fuel cost. Typically, concerns can be around safety because you might be going basically to suboptimal areas to fish because your preferred marine areas are closed. Area closures can have this sort of strong economic impact on related industries, but they can also have an impact on local communities just through restrictions on recreational use. So the ability to walk in a marine area, to swim in a marine area, those can be restricted as well. So we expect to see our ecological benefits translate into these economic and social benefits through this main pathway. We expect to have more fish, bigger fish, and more types of fish. And the easy sell for marine protected areas is that with the establishment of marine protected areas, we get this increase in recreational and tourism benefits. So the tourism one is pushed quite hard, that tourists really want to see larger, bigger, and more kinds of fish, and so we can capture more revenues from tourism by establishing marine protected areas. There's a lot of fine print involved in that, and certainly that's an area that my group is working in at the moment, looking at what these tourism benefits are. We've expect to see these benefits climate resilience. So we spoke about this briefly. I don't have the link here, but there, if anyone has seen, there's a few studies that were done after the tsunami in Thailand, which looked at areas with mangroves and intact coastal systems because they were not because they were protected, but just because they were intact, had fewer deaths and less infrastructure damage after the tsunami than areas which did not. And this is a real one that we expect to see. This is a big push for protected areas or for protecting coastal zones, is that we expect to see this improved resilience to extreme climate events. And these can be sort of, the crazy, awful environmental disasters like tsunamis or tropical storms, but they can also just be sort of the more day-to-day environmental impacts like tidal surge. So in the UK, for example, hard infrastructure on the coast has typically been used to protect against storm surges. And the cost of maintaining that infrastructure is really expensive. And the thought is that some of our green infrastructure, more intact coastal ecosystems could perform the same benefit and with much lower cost. And then, of course, we spoke previously about the benefits to scientific understanding of having these reference sites because we know what our intact ecosystems look like when they're free from human influence, or as far as we can get them. So how do we measure our economic and social benefits? So this is a schematic. On the right-hand side, we've got the costs, and on the left-hand side, we've got the benefits. And important specifically from an economic perspective is to understand how are these benefits that we expect from marine protected areas and the costs of our marine protected areas, how are they distributed across society? Obviously, if we've got one user group who are experiencing most of the costs and another user group who's experiencing most of the benefits, we're probably going to need some kind of intervention to address that imbalance. So the benefits that we expect to see from marine protected areas, we spoke about this biodiversity conservation in and of itself, habitat protection, and ecosystem resilience. So those are sort of three key benefits we expect. The economists amongst you may or may not have looked at market and non-market benefits. Maybe yes, maybe no. And typically we think of our total economic value arising from both our market and our non-market benefit streams. So when we're talking about total economic value, we can have this distinction of values which are traded on a market and which are easier for us to measure. So these can be, I'll show you. And then we have our non-market values, which are more difficult to measure. So what we typically see that as values get more difficult to measure, their tangibility to individuals decreases as well. So we can break up our total economic value by use value and non-use value. knowing that on average, typically our use values are our market values and our non-use values are our non-market values. So I'm sure if you've done any work on environmental economics, you'll have seen this schemata before, where we have our use values are differentiated by direct use, indirect use, and option value. So our direct use is that our outputs and services can be consumed directly. This is our fisheries, our tourism. And then we go all the way down to our non-use values, where we're looking at bequest values and existence values. So bequest value, if anyone is not familiar, these are the bread and butter of our non-use values, which we are typically assessing using the methods that I'm about to speak of. So our bequest value is this idea that I value an environment because I want future generations, usually my direct progeny, to benefit from a resource. And then existence value is the idea that I have value from a resource, even if I don't actually intend to visit it. It's not an option value where I want the ability to visit it in the future. I just like knowing that it exists. So pandas are a typical one here. I value knowing that pandas exist in the world, even though I have low expectation or maybe desire to see them in the wild. So how do we...
Katrina, sorry, just sorry to interrupt. Just to let you know that tomorrow we will have a lecture, Principles of Economic Valuation of Environmental and Resource Economics.
Perfect.
Yeah, I'm so sorry. You know, the order should be him first and then you, but you know the availability of this resource speaker is so difficult to make it in order. So yeah, so just don't worry about that. And they will get it the principle of this economic valuation tomorrow.
Oh, fantastic. Great. Okay, so this is your foreshadowing of what is yet to come. So I will go through these quicker, knowing that you'll see them tomorrow. So this is how we measure non-market benefits. We're thinking about effectively, you will see this tomorrow, but effectively we have our two ways of doing this, which is our stated and our revealed preference methods. So an example of a stated preference method in the marine setting, this was the work of Sean Pascoe and colleagues in the area which I have just visited in Australia. So Moreton Bay is right next to Brisbane, and it's a really large, beautiful marine setting, which has a lot of recreational fishing. And the concern was that they were rezoning the marine protected area. They were changing the activities that were allowed in different areas. And so these authors did a stated preference study. They did to understand what was the change in the economic value of recreational fishing because of the rezoning of the marine park. And actually, they showed that they had higher catch rates after the marine park rezoning, and that recreational benefits actually increased by 5 to 12% as a result of doing these changes. So this is really useful from a policy setting because it's a sort of an evidence base to say that as a result of this environmental action, we've actually increased social welfare. By contrast with our revealed preference methods, we are not observing behavior and how it's changed in relation to a policy intervention. Instead, we're asking people hypothetical questions. So if we were to put in a given benefit, in this case, thinking about marine protected areas, how would community value change, or how would social welfare change as we increase the size of the marine protected areas? So there's some examples you can look at from there. One of our problems is, that the non-market benefits, non-market elicitation methods are not very popular because they're subject to a whole bunch of biases. So there's no universal tool that's sort of readily accepted. And we worry that when we ask people, how much would you pay to achieve a given level of environmental protection? There's a strong incentive for people who would like that environmental protection to exaggerate how much they're willing to pay because they don't expect to ever have to pay it. And I'm sure you'll touch on this tomorrow. So there's a lot of biases. There can be other biases related to, I think that the person asking me wants me to hear that I have a large willingness to pay because it's within our social norms that we should conserve the environment. Therefore, I will exaggerate how much I'd be prepared to pay. Okay. So now we turn to the costs of assessing a marine protected area. cost should be, in theory, the easier benefit to measure because we have to pay the costs. And so if we have good records of how much we've paid, we should just be able to collate that information. So I suppose that's easier from an economic perspective. We can think of establishing the opportunity costs of lost fishing revenue, etc., etc. But what we typically need information on, and which is almost never available, is the establishment costs. So what are these initial upfront costs to establishing a marine protected area? These are related to research, planning, community outreach. And we see that establishment costs, we know from some work done in 2011 by Andrea McRae-Strub, this was pioneering work, that the costs of establishing a marine protected areas, as you might expect, are heavily influenced by the size of a marine protected areas. So if we've got a protected area, this is the one in Palau, which is 500,000 kilometers squared. This is the largest marine protected area at the time, compared to a tiny little one, which is 0.004 kilometers squared. We're going to have very different establishment costs. Also, which has a large impact on establishment costs, is the time it takes to establish a marine protected area. So these can be as little as 1 year, or they can go up all the way up to 10. And obviously, if you're going to take 10 years to establish a marine protected area, the costs involved with that are going to be much higher. Okay. One of the topics that I've alluded to throughout the day has been talking about effectively managed marine protected areas. And so the costs of maintaining or making sure that a marine protected area is effective and well managed are really quite substantial. So this was a study done on marine reserve effectiveness in Italy and whether enforcement was important. And enforcement is this idea that in order to stop people fishing in a marine protected area, we actually have to expend resources to ensure that they don't. So on the vertical axis are the log response ratios, and on the horizontal axis are the different marine protected area classifications. And effectively what they showed was that we only saw an increase in total fish biomass when we spent money, when we had enforcement in a marine protected area. These benefits don't just generate by themselves unless there's behavior change, and behavior change doesn't always occur unless we are enforcing the behavior change. So the final costs that I'll speak about are these compliance costs. And so again, we've got these really strong opportunity costs with complying with marine protected areas because we're losing fishing income, because we're not mining, because we haven't got aquaculture, because we haven't got tourism activity. And then a lesser well-known but highly topical area of costs in economics research are transaction costs. And these can be everything from the time it takes to learn and understand the regulations, to put in an application, the time it takes in order to report back on whether your intervention is effective or whether it's meeting the appropriate requirements. And so funders will often impose transaction costs on organizations or individuals who they have funded to create an environmental intervention like a marine protected area. And those reporting requirements will generate costs of themselves for the individuals or organizations. Okay, I think what we will do is we will leave it there. I'm happy to share these slides, Melanie, which is I've got just a little bit of information on how we design marine protected areas and how we can incorporate costs and benefits into the design of marine protected areas. But I'll leave you with this. This is our key challenges associated with estimating the cost of marine protected areas. Typically, we run into real problems when we have different objectives, and this will come because we have an NGO versus a fisheries management group versus a government organization. Our costs tend to be distributed along our establishment costs, our maintenance costs, and then we're limited by the data availability and how it's been aggregated. So these can make estimating the cost of marine protected areas, which should be the more straightforward task, far more difficult. So this is our large framework altogether. So in theory, we can go through and we can assess the values with each of these categories, our market costs or our non-market costs, depending on our research strategy. And then basically really related to data availability, we can get our costs associated with these areas. And look at this, I can skip all the way forward. Maybe I can. Yes, I can. So I will leave you with our key concepts. So we've spoken about what a marine protected area is, what we expect to see with marine protected areas, and then some of the economic and social outcomes, which can be really strong benefits, but also really strong costs related to opportunity cost, displacement, and the cost of management, and the difficulties with estimating all of these outcomes. And I will leave you all there and hope that you have the most wonderful rest of this conference or workshop.
Yeah, thank you so much, Katrina, for a very valuable presentation, very interesting presentation. Okay, do you still have time for discussion? How many minutes, Katrina?
Yeah, I can spend another few minutes in discussion.
Okay, all right. Maybe just three students. Yeah, we open discussion for 3 students.
Oh, great. Yep.
Yeah. Yeah. Maybe Doto. Doto. Yeah. Please.
Okay, Dr. Katrina, thank you so much for this amazing presentation. Actually, I'm not from biology background, but I'm very interested about this this presentation. Since just come from the country which we have a coastal area and we have this very serious problem like waste disposal, plastic, and even the what do we call it, illegal fishing activity. So based on your research, do you think this kind of mechanism you impose, it can be work maybe in some of African country, because most of African country most of the people depends on economic based on the marine natural resources. So do you think this kind of mechanism you impose, it can be work in other part of the world like Africa instead of UK or Australia or other area you have been researching on? Thank you.
So there's 2 aspects to this. One aspect is whether we think that a marine protected area will be effective or not. So some colleagues and I did some research along the lines of the sparing versus sharing debate. Is everyone familiar with this in an agricultural setting? So the sparing debate says we're going to set aside an area of land and we're not going to, we're going to have forest, or we're going to have some conservation activity. And we're going to concentrate all of our agricultural productivity outside that area. So we're going to spare that area. And the sharing paradigm says that instead of locking areas away, we will instead have low-grade agricultural activity over the entire landscape. So we will share the landscape. And there's been a lot of debate about whether we would actually, what are the ecological and the economic outcomes of these 2 different paradigms? Is it cheaper and more effective just to sort of lock up one area of the environment and then concentrate our impacts on the other area, or is it better to do the converse? So what we found is that from a marine protected area effectiveness setting, it's easier. It's actually, you get better outcomes for fisheries and better outcomes for conservation when you can share your marine spaces. So you don't have these highly protected marine areas. Instead, you have lightly protected marine areas where fishing is still possible. The problem that we found was that those are far more expensive to maintain. So for wealthier nations, it's a more effective strategy to share their marine environment and not have this really strict marine protected area protection, but instead to have, better managed fisheries, lower sort of grade fisheries impacts over the entire ocean space. But when you don't have the resources, it's actually more effective to lock away areas of your marine coast because it's easier to enforce a more discrete policy approach rather than it's easier to say there's no fishing allowed in this area and any boat is contravening that than to say, mesh sizes or, species and rules about bycatch, etc., etc. Some of our more nuanced fishery management techniques. So that's one point. The other point is that typically what we've seen in settings where we do have higher dependence from coastal communities on marine resources, we can minimize those impacts. We can sort of maximize the fisheries benefits and minimize the economic benefits if we can be a bit more flexible in our marine conservation approaches. And so we might just be having no take seasonal no-take closures. So we're not going to catch during the reproductive season, or we're not going to catch species X during these 3 months. Or we've got strict protection, but we're having, a bad year. And so we're going to, I think this was a case that happened during the pandemic, that some of the marine protected areas I can't remember the setting, were opened up during sort of social crises. And then they become sort of the bank, right? We can look to those marine areas in difficult times. So flexible management approaches, I think, can have increase the benefits we get from marine protection and decrease the cost to local communities. But if we're thinking about strict ecological outcomes, what we tend to think is that sort of softer regulation is not as effective at achieving environmental benefits. So ultimately, it depends on what your objectives are from your marine management.
Thank you, Katrina. Two more question. Yeah, I'll take Amin Oria Khail.
Yes. Okay, thank you so much for the opportunity and a great presentation. And it was a really interesting topic. Even my country is a landlocked country and far from the marine areas, but I'm really interested about these topics. So I want to ask, how can engineering and infrastructure investment in marine protected areas be optimized to balance ecological preservation with economic returns to the local communities? That's my question.
I just stopped sharing my screen, but let me go back. Share. So what a wonderful word you've used. Working in economics, we do tend to think about optimizing. So forgive the somewhat cartoon nature of this example. What we tend to look for when we're looking at optimizing outcomes is we go to some kind of optimization approach. And so we're thinking, important for those of you who've worked with optimization, it's really important to set your objective function. And so this is when it's important to say, is our objective to improve the welfare of coastal residents by X%, or to increase fisheries yields by X%, or is it we want to increase the likelihood of occurrence of different marine species, or the amount of protection in a habitat? So our objective is important. And then we talk about optimal spatial planning, where we discretize our environment. Here, apologies again, it's a UK example. This is off the coast of Wales. And we say we're going to discretize our marine environment into planning units or areas of focus. And then what we're going to do is we're going to think about what is the distribution of our ecological benefit through space. And we can do this through time, but the easiest one is to think about how our benefits are distributed for spatially. If we're considered purely about sort of species increase, we might be doing this for commercially exploited species, or maybe for species which have more of a recreational benefit or ecological benefit. Importantly here, in all settings, nudie breaks are my favorite. You won't really find nudie breaks off the coast of Wales, whatever. So what we typically will have is that within our species, we'll have far more common species, and then we'll have much rarer species. And so protecting our rarer species, if that is our objective, can be much more difficult because they're not everywhere, right? There's very few places where we can actually find them. So that's our layer of ecological benefits. And we can think of those benefits in any sort of context. We can think about maximizing fisheries production or recreational benefits, but whatever, we've got our benefit layer. And if we were just thinking about how can we best achieve those ecological outcomes, we might think to ourselves that from a spatial perspective, we'll protect this marine zone on this top left and then on this top right, and then we've protected all three species and we won, right? Well done us. What about cost is a typical question that we often have. So we might have if we're lucky, we have an easily identifiable and discrete distribution of costs through space, and we can assess those costs and how they may vary through space. And then we can map them onto our landscape, and we can think about, does where we would choose to conserve change when we think about the expense of doing so, the opportunity costs often of doing so. And this is the typical one. Well, we don't tend to protect, terrestrial zones in the middle of really populated cities. We tend to protect terrestrial areas outside of really densely populated terrestrial cities. And the same for the marine zone. So if our objective was to protect these 3 species, we might actually change our objective from sort of protecting the smallest amount of area to actually protecting more area, but in cheaper zones, because that's more effective and that has lower opportunity costs. So if we can identify how our benefits and our costs are distributed through space and time, so we can make this a temporal analysis, we can use these optimization methods to say, given our objective and our constraints that we might have, maybe a lot of the times our constraints are to do with, in the marine setting, with fisheries production. We need to be able to produce a minimum number of fisheries goods or to have a minimum amount of area available for infrastructure. How do we then go about best achieving our objective? So this is the work that was done in Wales, but I'm sure many of you have seen the software potentially. This is a free software developed by Hugh Possingham and his group out of the University of Queensland, so Marksan. It's a very quick and easy software that can be used to develop these optimal outcomes. Because important from a policy perspective is what we typically see. Those of you who work in agriculture will be familiar with this. There's no sort of, the optimal allocation of fertilizer is not 37.5 grams per, unit area. It's probably more like 37.5 plus or minus 10 grams. And so we have flexibility in what spatial configuration or what decisions we make in order to achieve our objectives. And that flexibility is really important from a policy or a community perspective, because it means that other values can be incorporated to sort of push and pull our solution around. Yeah.
Yeah, thank you. That's interesting. The University of Queensland developed that software.
Yeah, it's very easy to use now.
Yeah.
It's very widely used.
All right.
Thank you
Thank
so much,
you
Dr.
for the
Catherine.
explanation.
Thank you so much.
Yeah. Okay. Thank you. One more. One more question. Okay. I know. But no worries. Anyone raise hands and then doesn't get picked up, as you got still the point, yeah, for the scholarship. Okay. Okay. One more. Abdullah Ahmed. Abdullah.
I'm laughing.
Yeah.
Bribery,
Your
corruption.
question?
I approve.
Okay.
Katrina
Good
approve.
afternoon, everyone, and thank you to Professor Katrina Davis for a very impactful lesson on marine protected areas, MPS. My question is a question that will encompass like Elena Ostrom's governance institution of institutional governance. I have been thinking after this lesson and then taking like insight from Elena Armstrong's institutional form of governance. So marine protected reserves, yes, areas are there because there is no one like that is totally controlling them. Is this marine protected areas a kind of like a substitution because of lack of property rights in the marine ecosystems as a response to maybe common pool resources issues? Or marine protected areas is just a policy substitution because of the lack of stronger property right, like I said, as an exception to common pool resources like marines? That's the question.
Well, it's as if you guys have read my mind and asked questions and all this stuff that I did not have time to talk about. So absolutely, using Eleanor Ostrom's theory of common property is an excellent way to think about marine settings, because typically it's exactly the tragedy of the commons. So what I suppose is interesting from that perspective is that we've seen where we have stronger traditional management of marine resources, on average, we have observed better ecological outcomes. So this is in Local management. It is the Philippines. So parts of the Philippines have still got parts of their traditional tenure systems in place. And typically we've observed that the adoption of marine protected areas has been better because they're community driven and the marine protected areas sort of map onto their existing institutional structures already. And B, just that areas which have a stronger sense of collective management and on which there's sort of better units of organization within the community, they tend to have better outcomes. The marine regulation that has attempted to overcome this lack of property rights, which typically leads to poor outcomes in marine settings, is to introduce user rights. And so a popular strategy, which has been worked really well in Japan and also in Chile, are called territorial user rights fisheries, and actually in Vietnam. So a colleague of mine is working with turfs there called territorial user rights fisheries in Vietnam. And so what these areas do is that they ascribe property rights and typically to existing users, grandfathering. And so they say, you're already managing it, and we're going to legally recognize those rights. And so what, again, we're trying to do is we're shifting the incentive structure. And so we're saying all of the costs incurred for, the opportunity costs of leaving that individual in the water until it's bigger next year and it's more fecund next year. We have higher reproduction next year. The costs of those choices or the management, you will then get to incur the benefits of those costs. And so we're internalizing the costs, but also internalizing the benefits. So territorial user rights fisheries are one of the ways that that marine regulation or management is attempting to overcome this lack of property rights. Tricky thing is that we have highly mobile species in the marine environment, so it really works best for shellfish or sessile species. So Chile, for example, it's the Chilean abalone, which is most typically managed through these turf systems. And they don't apply to pelagic or demersal species, which have larger home ranges. Yeah.
Thank you very much.
Thank you. Okay, no more question, yeah. Okay, Katrina, thank you so much. You know what, Katrina, have you visited the Thousand Islands in Indonesia? Yeah.
I was a child when I visited Indonesia. I haven't been back as an adult. It's terrible.
All right. Okay. Yeah. What's interesting, next week, our summer course, me and the students will go to this island in the Thousand Island Regency, and sadly, this islander, they already practice nature conservation for their food security, also, yeah, for like their livelihood, but now they're having this property rights problem.
Okay.
They're fighting with this resort company. So I believe that what you shared today will equip the participants for excursion next week. Yeah.
Wow, how interesting.
Very fruitful. Yeah, Katrina, come on. Next year you go with us for this summer
Yeah,
course.
I'd love to.
We go to that island.
Yeah. It sounds
Yeah.
amazing.
All right. Once again, thank you so much, Katrina. We appreciate so much. That's really interesting and very fruitful presentation. So let's give applause for Katrina. Thank you so much.
Thanks very much, guys. And thank you for those excellent questions. And I
All
hope
right.
the rest of the course goes very well and enjoy the excursion next week.
Yeah. Okay. Thank you. Thank you again.
No
Okay,
problem.
guys. Okay. Let's see tomorrow, okay, for the next lectures. Okay, Katrina, thank you.
Thanks,
Bye-bye.
everyone. Bye.
Bye-bye, everyone.
Bye.
Thank you.
Bye.
Assalamualaikum. Good evening.
Walaikum salam.
Waalaikumsalam.